Here in this question, we have to find the minimum number of, we have to find the chromatic number of cycle graph with 7 vertices. Chromatic number is nothing but minimum number of colors needed to color the vertices such that no two adjacent vertices have the same color. Chromatic number of a cycle graph with n vertices is given by chromatic number of Cn, cycle graph with n vertices. It is represented by Cn is given by n minus 2 into n by 2 flooring function. This is 2 n by 2 plus 2. This is the formula for finding chromatic number of cycle graph with n vertices. So here we have to find the chromatic number of Cn. N is 7 here. 7 minus 2 into 7 by 2 flooring function plus 2. So 7 minus, this is 3 point something, 3.5. 3.5 is flooring function 3.5, nothing but 3. So 2 into 3, 6 minus, plus 2. 7 minus 6, 1 plus 2, 3. So here we can say chromatic number of cycle graph with 7 vertices is 3. In shortcut, we can say if n is even, then chromatic number of Cn is 2, and if n is odd, chromatic number of Cn is 3. Here given number of vertices is 7, which is odd. So the chromatic number is 3. So your correct option is option C. The number of elements in the smallest equivalence relation over set A with mod A is equal to n. Here 4 options are given and we have to find the correct option. A relation is equivalence if it is reflexive, symmetric and transitive. If R is a relation on A, then it is reflexive if x relates to x for all x belongs to A. It means if it contains n elements, then minimum n elements should be present if it has to be reflexive. Let us suppose A contains elements 1, 2, 3. Then relation R is reflexive. Then it should contain 1, 1, 2, 2 and 3, 3. And the remaining are optional. So minimum it should contain n elements. These are the diagonal elements. That means 1, 1, 2, 2, 3, 3, so on. It is symmetric if x relates to y, then y should relate to x for all x, y belongs to A. If x relates to y, then y should relate to x. Then only it is symmetric. And what is transitive relation? If x relates to y and y relates to z, then x should relate to z. Then it is transitive. A relation R is equivalence if it is both if it is reflexive, symmetric and transitive, then only it is equivalence. Here we have to find the minimum number of elements and an minimum number of elements. We have to find the number of elements in the smallest equivalence relation. If it has to be equivalence, it should be reflexive. In reflexive relation, at least n elements should be there. That means, as we discussed earlier, all the diagonal elements should be there. Let us take this as example. 1, 1, 2, 2 and 3, 3. This is the relation. Let us suppose this is a relation. It is relation R on A, which contains elements 1, 2, 3. Here this is reflexive. Why? Because all the diagonal elements are present, and it is symmetric. If one relates to, what is symmetric? If x relates to y, then y should relate to x. So we can say this is also symmetric, and this is also transitive. If x relates to y and y relates to z, then x relates to z. If these two things are not there, then this need not be there. So we can say this is also transitive. So we can say this is equivalent relation, and the minimum number of elements and the number of elements in this is n. That means 3. Here A contains 3 elements. So here this relation contains 3 elements. So here we can say the number of elements in the smallest equivalence relation is relation on a set with n elements is n, and those are the elements needed for the relation to be reflexive. So here correct option is option A. Using recursive program of stack, which of the following translations can be done? Option A, infix to prefix. Option B, prefix to infix. Option C is both option A and B, and option D is none of these. While we are converting infix to prefix and prefix to infix, we use recursive program of a stack. So here correct option is option C.